Good day, learners. Welcome to Technical Mathematics lesson. My name is Mathule Latakomu. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Good day, grade 11s. Today's topic, we are going to focus on functions and graphs. And this topic is the one that you are currently doing. So without any waste of time, let's look at our lesson objectives. At the end of this lesson, learners must be able to sketch the parabolic and hyperbolic graphs. They must also be able to write down the range and domain of the graph and understand the effect of parameters on the graphs. So now let's look at our parabolic function. Remember, with a parabolic function, it comes in two standard forms or in two methods. So the first one, we having y is equal to ax squared plus bx plus c, and the other one, it comes in a method of y is equal to a into x plus p all squared plus q. So those are the two different types of parabolic functions. So now, remember, in a parabolic function, we do have the shape of the graph. And the shape of the graph, remember, it's either is going to face down or is going to face upward. Then, what affects the graph to face down or what affects the graph to face up is the effect of A. A is the one that will determine whether the graph is going to face upwards or the graph is going to face downwards. So what happens now with A? If A is less than 0, of which your A is negative, remember any number that is less than 0, it's a negative number. A is negative, then you will have your graph being said. And remember, as we sketch our graph, we have what we call the axis of the symmetry of the graph. Axis of the symmetry, it cuts your graph into two equal parts from left and right. And then now we also have our x-intercept out together. And then now we also have our y-intercept and vertex. Vertex, we can also call it a turning point. A turning point. So for you to determine or to sketch a graph, you need to have all those points that I'm talking about. You need to have your x-intercept, your y-intercept, and your turning points. And also indicate your axis of the symmetry. So now, if your graph now, you have A that is greater than 0, it means now your A, it will be what? Your A, it will be a positive number. And if A is a positive number, your graph will face upwards. So since your graph will face upward, you know you also have to get your x-intercept, your y-intercept, and also the axis of the symmetry. And remember, I said axis of the symmetry, it cuts your graph into two equal parts from left to right. It means the distance from the symmetry to your x-intercept on your left and the distance from the axis of the symmetry to your x-intercept on the right, they are equal. Okay, so now the steps on how to sketch the parabolic functions. Remember, if a parabolic function it's given in the form of y is equal to ax squared plus bx plus c, then what are the steps to follow when we're sketching a graph when it's given in this standard form? So the first step is to determine the y-intercept. You need to determine your y-intercept where x is equal to 0. And then now, the step 2, you have to determine your x-intercept where your y is equal to 0. Remember, y-intercept x is equal to 0 and y-intercept x is equal to 0 and x-intercept y is equal to 0. And now, with this graph, the step 3, you have to determine your turning point. And as you determine the turning point, the x value of the turning point is given with the equation where it says y is equal to negative b over 2a. And remember, this type of equations, they are there in your formula sheet or information sheet. So you just need to identify them, that when you're using x is equal to negative b over 2a, then that's where now we're talking about the axis of the symmetry or the x value of the turning point. Then the step 4, finally, that's where you plot all the points and coordinates on a Cartesian plane and you sketch your graph. So now let's see how do we apply these types of steps. The first one, where we have activity 1, number 1, it says you must sketch the graph of f of x. And then the f of x is given as negative x squared plus 4x plus 5. So that is our functions that we need to sketch together. Then now we have to determine the first thing that we need to determine is the y-intercept. So we have to determine the y-intercept. And remember, I said when we determine the y-intercept, it means that your x is going to be equal to 0. And the second step, now you determine the x-intercept. And remember, when we determine the x-intercept, your y, it will be equal to 0. And then now the step number 3, when we have to determine the turning point, you will determine the turning point. Firstly, you will use your equation or formula that says y is equal to minus b over 2a. Only when the standard form is given in a form of f of x is equal to negative x squared plus 4x plus 5. So finally, the step number 4, that's where we are going to sketch our graph. So now let's see how do we calculate or determine those intercept and turning points. So with the first one is y-intercept. We know that where x is equal to 0, and now it means where I see x on this function, I have to substitute 0. So we're going to say y is equal to negative, then we substitute 0 plus 4. Where you see x, we substitute 0. So now you will go and punch into your calculator, and as you punch in your calculator, you will realize that the answer that we get there is positive 5. So now if we want to put it in a coordinate form, then your point, it will be 0 and 5. Remember, we said x is 0 and y is 5. So now it's your coordinate form. Then from there, we go to the second one. The second one, remember, they're saying we must determine the x-intercept. The x-intercept where your y is equal to 0. Correct? So now it means on our function, remember, y and f of x, they represent the same thing. Correct? So now where is f of x? There is the value of y. F of x means there is a y value there. So where there is y, we put 0, then we're going to have negative x squared plus 4x plus 5. Correct. So now, in this term now, our equation is equal to 0. We need to solve for x. And remember, as we solve for x, we can use either quadratic formula or we factorize. Correct. But it's simpler and accurate if we use our quadratic formula, so that you don't have to stress about your signs and factors. So quadratic formula, it makes your life becomes a little bit easier. So what is the formula for quadratic formula? It's x is equal to minus b plus minus the square root of b squared minus 4a C. And from there, remember, you have to do what? You have to substitute. Remember, when you substitute, always you must use the bracket. When we substitute, always make sure that we use the bracket, and your formula, it has to look exactly as the one that you find in your information sheet. Remember, my square root, I wrote it in full. My square root it doesn't have to be like this. Everything under the square root, it must be covered. And also your division sign, you don't have to cut it like that or you put it like that. So your division sign have to be long enough to cover everything that is on your numerator. So now we have to substitute. Remember, as we substitute, the value of A there is going to be -1 because there is a ghost 1 there. There is a ghost 1 there in front of X. So it's -1. That is the value of A. And the value of B is +4, and the value of C is +5. Correct? As you take you pick the value or you indicate the values on your equations, you must make sure that you also take the signs of those values. Correct? So now when we substitute, we're saying B is 4. Where is B, we have to substitute 4, and also where there is B there, we substitute 4. And then now we have to substitute A. A is what? A is -1, and C is equal to 5. Then from there we know that our A is equal to 1. Then now you have to take your calculator and you determine the values of X. So another thing that is challenging is when learners have to punch this on their calculator. So you need to be accurate on how you punch these values in a calculator. So now, if you have the root sign of 4 plus the square root of 4 squared minus 4 into -1 and 5 all over 2. 2 into -1. Remember, your A there have to be -1. So what do we have there? So remember, in this case, you are going to have your X as -1, and your Y is going to be, other X is going to be 5. So that's how you are going to get the values of X. One value of X there is going to be -1, and the other one there is going to be 5. Or remember, I said you can factorize, but when you factorize in this case, then you will have to see x squared minus 4x minus 5, then you have to open your bracket. So you will have x minus 5 and x plus 1. So when you factorize, you can see already that the factors there will be the answers that we got there using our quadratic formula. But for now, don't stress about factorizing. You only focus on a quadratic formula because it's more effective and easier to use, and it will be more faster for you to answer this type of question. So your coordinate is going to be -1 and 0 and 5 and 0. Remember, we said y is 0. Correct. So that's how you determine your x-intercept. Okay? So now, have to calculate the turning point now. Remember, we said the turning point, you have to identify this type of a formula in the information sheet, where x is equal to minus b all over 2a. We know our a is equal to -1, our b is equal to 4, and our c is equal to 5 in this case. So now we just have to substitute our b and also substitute our a. our b is 4, our a is negative 1. So as you substitute this, you are going to get your x value as what? As 2. So how, after determining the x value, you are not done because a turning point is a point, and a point has x and y. Then now, how are you going to get your y values? You can simply substitute 2 into the original equation. We have 2 here, and we also have 2 there. So now you will just punch it in your calculator, and then you will see what is it that you are going to get. So we have negative into 2 squared plus 4 into 2 plus 5. So you will find that the answer that you get there is going to be 9. So now, your points now, your turning points now, is in a form of x, which is 2, and y, which is 9. So that is your turning point. So remember now we have identified or we have determined everything that we need for us to sketch the graph. Remember the first thing, we have calculated the y intercept where x is equal to 0, and our y, it was 5. The coordinate of y intercept was 0 and 5. So we also determined the x intercept where y is equal to 0, and the coordinate of x intercept was negative 1 and 5. And then we also calculated the turning points. Then our turning points, the point was 2 and 9. And then now we have to sketch our graph. So now, when we have our Cartesian plane, we know that on our Cartesian plane, we are going to have 1, 2, 3, 4, 5, 6, 7, 8, and also this side is negative 1, negative 2, negative 3, negative 4, negative 5. Then we have negative 1, negative 2, negative 3, negative 4, negative 5. Moving up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. So now, remember our value for y-intercept was 0 and 5. So when we go to our function, we're looking at 0 and 5. 0 and 5 is that point we write there, 0 and 5. The first point that we got on our graph. And then now, the second one is the x-intercept. Remember, we have negative 1 and 5, and you go on your x-intercept. On the x-intercept, we have negative 1 and positive 5. So we also put those points there, negative 1 and positive 5. Correct. So now we have to now plot the last one, which is the turning point 2 and 9. That is a point there, which is 2 and 9. That is our turning point. So now, the nice part about this one, you must know that the minute you have identified this point and you have plotted them, already in the exam you find that plotting this thing you get something like 4 marks. Already your 3 marks, it's on 1 mark for the 2 x-intercept, 1 mark for the y-intercept, and 1 mark for the turning point. So already out of 4, you have 3 marks. You have 3 marks out of 4. And then the 4th mark, when you get it, is to show the shape of the graph. So now the shape of the graph, you can see that from the turning point, it will pass 5 and negative 1 on your left hand side, and on the other side, it will just pass 5 there where there is x. So this is how you will be sketching your graph. Correct? And then now, remember I spoke about the the equation of the symmetry. You can see that after plotting this graph from 2, which is the the x value of the turning point, and the equation of the symmetry is x is equal to 2. So from 2 moving to your right, we move 3 units. 1, 2, 3. Then from 2 moving to your x coordinate on the left, we move 1, 2, 3. So you can see that the equation of the symmetry, it divides that graph into 2 equal parts. So now a question may come again and ask you to determine the domain. And domain, we are talking about x values. So when we are talking about the domain is where the graph is defined. Where the graph is defined on the x axis. Correct. So this graph is defined on the x-axis at any x value. Any x value you substitute on the functions that is given, you are going to have a output, which is x is element of all real numbers. So now, when we're talking about range now, we're talking about y values. And then we're talking about the y values where the graph is defined. So we can see that from the y-axis, from the y-axis, the graph is only defined from positive 9. If you can write point 10 there, the graph is not defined there at 10. So what does it mean? It means that our graph starts to be defined where y is equal to 9, going downwards. And then we can see with arrows that this graph, it continues, we don't know where it ends. So now the range will be y is less than or equal to 9. When we're saying it's less than or equal to 9, remember the value of 9 is included as well. So the range there is y is less than or equal to 9. It means y is less than on all the values that are below 9, from 9 going down. So that's how we determine our domain and range of this function. I hope it was clear. Moving forward, we have now the same parabola, but now we have to sketch it when we are having this form now, where we have y is equal to a into x plus p all squared plus q. So now, steps on how to sketch the parabolic function when you are given this type of the form. This type of a standard form. So now we have step 1 where you have to determine the turning point, correct? And then step 2, we have to determine the y-intercept where x is equal to 0, and we have to determine our x-intercept where y is equal to 0. And then we also have to plot there. So now, when we start here with the turning point, we must know that the value of P and the value of Q, they represent our turning point. The value of P and the value of Q, they represent our turning points. So now, let's look at the steps on how to sketch this particular function using this method, this standard form. So now we can see that we are given the sketch, the function there. The function is given by g of x is equal to x plus 1 all squared minus 9. Then the first thing is to determine the turning point. We determine the turning point, and the second step, we determine the y-intercept, the x-intercept, and we sketch. So now, let's look at how now do we get our turning points. Most of the learners, when we have to determine the turning point, they make a mistake of taking the value of P the way it is. For instance, they will say the x value of p is 1 and the y value is -9, of which is incorrect. So now I want to show you on how do we write this one in the correct manner. You take what is inside the bracket. What is inside the bracket is x plus 1, and you equate it to 0. Always you do that when you're determining the turning point. After equating to 0, then that's where you transpose your +1, then x, it will be -1. X, it will be -1. So that's how you get the x-intercept, the x value of the turning point. Then now, for you to get the y value of the turning point, you look at that value there. You take it with its sign. In this case, we have -9, so we just put y is equal to -9. That's how you get the x value and the y value of this graph, the turning point of this type of a function. So now, the turning points now, it will be in a form of -1 and 9. That is the coordinates of the turning points. It is clear. I repeat myself. You take what is inside the bracket and you equate it to 0. Avoid just taking that number the way it is. It's incorrect. You have to equate it to 0, then you solve for x. So that's how we determine the turning point. It was just simple. Now, determining the y-intercept, this one, I think it's clear. We know that y-intercept, x is equal to 0. In this case, we know that where there is x, we put 0. So we're going to have y is equal to 0 plus 1 squared minus 9. So when you punch your calculator, 1 plus 0 is 1. 1 squared is still 1. When you minus it by 9, then you get -8. So that is the value there. Then we're going to have what? We're going to have the coordinate as 0 and -8. Correct. That's how you determine your your y-intercept. So now we go and look into our x-intercept. So our x-intercept, remember, y is equal to 0. So now, how do we determine our x-intercept having the equation like that one? So now, remember, we have to equate it to 0, and we're going to have x plus 1 squared minus 9. Interesting one. Interesting one. Most of is not equal to, sorry, it's just -9, not equal to -9. Is -9. So now, there we have to solve for x. We have different method of how do we solve for x when it's like that. But the simplest way is to now transpose this 9 to the left-hand side. When you transpose that 9 to the left-hand side, you're going to have +9. Then we're going to have x plus 1 squared. Then now, our aim is to get rid of the squared there. And how do we get rid of the squared? We introduce the square root both sides. So as we introduce the square root both sides, don't forget to indicate plus minus. Correct. So now, the square root now will cancel our squared there. And then now, we're going to have plus minus. What is the square root of 9? The square root of 9 is 3. Then you're going to have x plus 1. You remove the square root there, then you're going to have x plus 1. But in this case now, what you have to know is that we have two values of y. We have two values of y. One is -3 and the other one is +3. So how do we work with those values? We're going to start by saying +3 is equal to x plus 1, then, or -3 is equal to x plus 1. So you can see that I've separated the two values of y. The other one was positive, the other one is negative. So now solving for x, we take this positive one, we transpose it, we're going to have 3 minus 1 is equal to x. Therefore, x, it will be equal to 2. Then now if we transpose this positive one, we're going to have negative 3 minus 1 is equal to x. Therefore, x will be negative 4. So now we know our coordinate is 2 and 0, and the other one is negative 4 and 0. That's how we determine the x-intercept in this equation. You must practice it. It's as simple as ABC. Remember, the key word when we introduce the square root, you must have plus minus. So if suppose that you forget to write plus minus there, it means you are going to end up with 1x value. So you always make sure that you have plus minus so that you can have 2x values at the end. Then now we are done determining our x-intercept. Then we need to sketch our function. Remember, we have our turning point, which is negative 1 and negative 9. Negative 1 and negative 9. Sorry. This turning point here is negative 1 and negative 9. I wrote it correct there. Then when I write it as a coordinate, I forgot to put negative there. So it's negative 9 there. It's negative 1 and negative 9. Then now we have our y-intercept is 0 and negative 8. And we also have our x-intercept, which is 2 and negative 4. So now we go and have our negative 4, correct? We have negative 4 this side, and then this side, remember, we have 2. We put it in a coordinate form, we're going to have negative 4 and 0, and with this side, we're going to have 2 and 0. And remember our y-intercept was negative 8, negative 8, we can see it somewhere there. We have negative 8 there, and then the coordinate was 0 and negative 8. Those are the coordinates of the y-intercept. Then the turning point, it was negative 1 and negative 9. So the turning point then, remember, on the x value of the turning point, we have the axis of symmetry. The equation there is y is equal to negative 1. That is the equation of the axis of the symmetry. So the point then is negative 1 and negative 9. So now we can see as we sketch that our graph will be a happy function. It will face upward. It will face upwards. And remember, we said when we mark, one mark is going to be for x values or x-intercept. Then the second mark, it will be your y values, the correct one. Then now the third one is going to be your turning point. Turning point. Then the turning point, there's a mark, and the last one is the shape of your graph, the shape of the graph. So that's how you obtain the 4 marks on how to sketch this type of a graph. Remember, here I'm only talking about the sketching, how to sketch your graph, correct? And then when we speak about the domain, we're talking about x values. So the domain of this function, remember, this function is defined on all x values. On all x values. So x is element of all real numbers. Is defined there. So the range now, the range, we're talking about y values. Remember, The range is where the graph is defined on the y-intercept. So now, the turning point is -9. It means below -9, if we say -10, the graph is not defined there by -10. So the graph is start to be defined from -9 going upward. It start to be defined from -1 going upward. It means the minimum point on this graph is -9 on the y values. So now the range is going to be y is greater or equal to -9. Remember, -9 is included. That's why I'm using y is greater or equal to -9. So that's how you sketch the two graphs of parabola, and then in two different methods, and how to identify their turning points, the x-intercept, and also how to read their domain and the range. So that's how we sketch this type of functions. So now, we have learned how to sketch the function in both forms, correct? When it's given as y is equal to ax plus bx plus c, and also in a form of y is equal to a into x plus p squared plus q. Now, after sketching the graph, sometimes you will be required to determine the equation. So, I will also show you how to determine the equation in two ways now. To determine the equation when they need the equation in this form, where you have to determine in y is equal to ax squared plus bx plus c. So to determine the equation of a function when given the graph, they will sketch the graph for you and they ask you to determine the equation from that graph. The first thing that you need to do is to identify the type of a graph that is given, correct? And then the step number 2 is to identify the given information on that graph. You must analyze the graph and then get the given information. Then from there, you are going to use this type of a formula. And this one is not there in your formula sheet. It means you must know it by heart. It's y is equal to a into x minus x1 and x minus x2. To determine the equation in this standard form, we have to use this type of a formula. So now, let me show you how to use that type of a formula. Remember, the question will come and say, determine the equation of the graph in terms of y is equal to ax squared plus bx plus c. So now, we are given a graph. Our graph, as you can see, we have two intercept, the x-intercept. We don't know what is our turning point. We don't know what is our y-intercept. The only thing that is given is the two values of the x-intercept. Remember, we have y-intercept and x-intercept. So those two coordinates are the ones that are given. And on the graph, we also know what is our point. We have two intercept and one point. We have enough information for us to determine this type of equation. So what do we do here? We're saying on the left-hand side, we mark it x1, and on the right-hand side, we mark it x2. It means your x1 is -2 and your x2 is 3. Remember, I said you must know this type of the formula in order for you to determine this particular equation. So now we have y is equal to a into x minus x1, x minus x2, correct? Then now we have to substitute the x1 and x2. So we still have to write it there, x minus, now x1 is -2, and x minus x2 is 3. Correct? So if I were to simplify that, I will have y is equal to x Remember, we multiply inside the bracket there. Negative multiplied by negative is going to be positive 2. Then negative multiplied by positive there, we're going to have negative 3. Correct. So now we can see that we don't know what is the value of A. That's why we are having 1 point on the graph, which is 4 and 6. So the point on the graph, which is 4 and 6, will help us to determine the value of A. Will help us to determine the value of A. And how are we going to determine the value of A? Remember, I will have to substitute negative 4 where there is x, and substitute 6 where there is y. So let's substitute. I'm going to have 6 is equal to A into 4 plus 2 and 4 minus 3. So if you can check them, where there is y, I substituted 6, and where there is x, I substituted 4. So now we have to determine the value of A. How are we going to determine the value of A? We're going to have 6, it's equal to A into 4 plus 2 is 6, 4 minus 3 is 1. So we're going to have 6, it's equal to A into 6. So for us to get the value of A, we're going to divide both sides by 6. Then our 6 cancel 6. Therefore, the value of A is going to be 1. If you see 6 divided by 6, you get 1. Then now, we take this value of A and we come and substitute it here. We need to substitute the value of A. Remember, they said the diagram has to be in a form of y is equal to ax squared plus bx plus c. So now, we substitute the value of A, which is 1, into x plus 2, x minus 3. So now we can remove the bracket and expand it. So now, as we expand, we're going to have 1 into. Now, we use our FOIL method. X multiplied by x, x squared. X multiplied by negative 3, negative 3x. 2 multiplied by x plus 2x, and 2 multiplied by negative 3 is negative 6. So now we are going to have y is equal to 1 into. Inside the bracket, we have the like terms there. So it's going to be x squared minus x minus 6. So when you multiply by 1 inside the bracket, it's not going to change anything. So we're going to have y is equal to x squared minus x minus 6. So you can see the steps of how to determine the equation of the graph when you are given the 2x intercept and 1 point on the graph. This is the method that we are using. Remember, this type of a formula is not on a formula sheet. It's important for you to know it. And then how to substitute your x1 and y1 and simplify it. And after simplify it, for you to get the value of A, you need to look on your graph to see if ever you are not given any point except this intercept. Correct? Then after that, you substitute them. After substituting, you calculate for A. After calculating for A now, you are going to substitute A back to the equation there. Then you expand it. As you expand, you can see that the equation is in a form of y is equal to x squared minus x minus 6. So that's how you determine the equation of the graph. Now, let's look at another way of determining the equation. Remember now, our equation, it has to be in a form of y is equal to a into x plus p squared plus q. So now, when we determine this type of equation, we know that P and Q represent our turning point. It means in this case, we are going to see the turning point on the graph. And after seeing the turning point on the graph, then you can see one other point on the graph. Then now what do we do now? We use the turning point and one point on the graph to determine the equation. And how do we do that now? We have x is equal to 8 and y is equal to x is equal to 1, sorry, not 8. X is equal to 1, y is equal to 8. Correct. Those are our values of the turning point. So from the x1, remember we're going to have x is equal to 1. So now we can't take this one straight to P. No. Remember, it has to be an equation that is equated to 0. So now, how am I going to make sure that this is equated to 0? I will take this one and I transpose it. I will have x minus 1 is equal to 0. Then this is going to be inside the brackets there. That's what I will take inside the bracket. You can see there is a difference between the positive 1 that you will take there or negative 1. So for you to determine how are you going to substitute, you need to firstly convert that equation to be equal to 0. Then from there, you can take it inside there. And then y is the same as the value of q there, which is 8. So when you substitute, you're going to have y it's equal to a into x minus 1 squared plus 8. So that's how you determine, that's how you substitute those values there. Correct. So now, 1 point on the graph is there for us to determine the value of what? Of a. So remember the points there is what? Is 2 and 6. So where there is y, we put 6, a, and then where there is x, we put 2 minus 1 squared plus 8. And then we have to make a the subject of the formula. And how do we make a the subject of the formula? It will be easier for us if we transpose this positive 8 to the left-hand side. So we can do it here. We're going to have 6 minus 8. We're going to have 6 minus 8. It's equal to a. Now, if you say negative 2 minus 1, you have 1. And 1 squared is 1. So now we're going to have your a like that. So therefore, your a is going to be negative 2, because 6 minus 2 is 6 minus 8 is minus 2. So your function, it will be y it's equal to minus 2 into x minus 1 squared plus 8. So that's how you will be determining your equation there. So this one is simple. If you are given the turning point and 1 point, that's how you determine that type of a function or a graph. Correct? So now we have learned how to sketch these two types of graphs and how to determine their equations from the graph. So that's what you need to understand going to your exams. Okay? Now let's check the next functions that we have. We have a hyperbolic function. And a hyperbolic function is given x, y is equal to a over x plus q. And remember, the value of a or the value of q, they will forever change. Even those variables, sometimes they can put k where there is a and they put p where there is q. It's not always that it has to be a there and q there. We have different types of textbooks. You just have to know that those variables can change. So now, this type of a graph, we know that we have quadrants. In a quadrant, you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Also here we have quadrant 1, 2, 3, and 4. So now, you can see the effect of A, that when A is greater than 0, it means when your A is positive, we expect the shape of the graph to be in quadrant 1 and quadrant 3. Then when A is less than 0, which is negative, when A is negative, it means we expect our graph to come from quadrant 2 and quadrant 4, the shape of the graph. And then one important thing about this graph is that we have what we call the asymptotes. The asymptotes, it's where the graph is undefined. Correct. It means it is not happening. Asymptote is something that can happen. Are we together? Where the graph is not defined. So we have the one for x asymptote where x is equal to 0. The first equation of the asymptote is x is equal to 0. And this one is always like this in technical mathematics. It's always like that. Why are we saying x is equal to 0 as an asymptote? Remember, asymptote is where the graph is undefined. If we put 0 where there is x in this equation, anything divided by 0 is undefined. Hence, the first asymptote is x is equal to 0. It means where x is equal to 0, our graph is undefined. Then, the y equation of the asymptote, it's where y is equal to the value of q. So y is equal to the value of q. Any value that you see there for q, you equate it to y. Those are the two asymptotes of this function. So now, without any waste of time, let's look at how to sketch this type of a function. So remember, we're saying how to sketch the graph of a hyperbola. The first thing that you need to know is to write down the equation of the asymptotes. And then now, the second step, we have to determine the x-intercept where y is equal to 0. Correct. Remember, in this type of function, hyperbola, in technical mathematics, the graph is only affected by the y-asymptotes moving up and down. It means you're only going to get the x-intercept. You are not going to find anywhere they are telling you to determine the y-intercept of a hyperbola. You are only going to be asked to determine the x-intercept in technical mathematics. So remember, we also have the horizontal asymptotes and the vertical asymptotes out together. Then now we have to sketch our graph. So without any waste of time, let's check how do we sketch this type of a graph. The first graph that we have to sketch is given by y is equal to 3 over x plus 1. Then remember, we said if this value is positive, we expect our graph to be in quadrant 1 and quadrant 3. That is how the shape of this graph will look like, because the value there by a is positive. So now we have to determine our equation of the asymptotes, x-intercept, and we sketch the graph. And also we have to be able to write down the domain and range of this type of a graph. So now let's look at the equation of the asymptote. Remember, I said the first one is going to be x is equal to 0. That is the first equation of the asymptote. That is always like that, because this type of question, it can come in 2 marks. So 1 mark will be for x is equal to 0, and the second mark is y is equal to positive 1. So you get 2 marks there. So the important thing about the equation of the asymptote is that you have to write it in a form of equation. And in a form of equation, it's when x is equal to something or y is equal to something. If, for instance, you say, I want to determine the equation of the asymptote, and you're saying, oh, I know that is 0 and 1, you are going to get totally wrong. We don't know what is 0, we don't know what is 1. So you have to write it in a form of equation by saying x is equal to 0 and y is equal to 1. Remember, the equation of the asymptote, we get it from that positive 1 there. Correct. So this is how you write the asymptote, and then you get your full 2 marks. Then now, determining the x-intercept, we know that our y is equal to 0, so 0 is equal to 3 all over x plus 1. We will transpose this to the positive 1 to the left-hand side. We have negative 1. It's equal to 3 over x. So we can multiply both sides by x. Then we know that x will cancel x this side. So we are going to have negative x is equal to 3. So we divide both sides by negative 1. Remember, we divide by negative 1 so that we can get our positive x there. So x is going to be negative 3. That's how you determine the x-intercept. So the first mark we're going to get there by equating to the equation to 0, and then we have the x-intercept there. So also this type of a question, it can come in 2 marks. So you just have to make sure that you know how to substitute your 0 and how to simplify to make x the subject of the formula. Okay? So now the second step now is to sketch our graph. Remember, when you sketch your graph, the first thing that you need to indicate is the asymptote. You need to indicate your asymptote. So what are your asymptote? Your asymptote are what? Are x is equal to 0 and y is equal to 1. So in this case, x is equal to 0 is this line. X is equal to 0. And then now your y is equal to 1. Y is equal to 1 there. Then we have another equation of the asymptotes where y is equal to 1. So that's how you get the asymptotes. Correct? From there, we calculated the x-intercept. They said is negative 3. So we have negative 3 here. Negative 3. Then now, for us to sketch this graph, we're going to have a shape like this. So that's how you determine or how you sketch this type of a graph. That's how you sketch this type of a graph. Remember here, when we mark, we're going to give you marks for asymptote and marks for the intercept and a mark for the shape. How to get. That's how you accumulate your marks there. Then now, coming to the domain. We're speaking about x values, remember. I said the domain is where the graph is defined on the x-axis. So we can see that this graph is only undefined when x is equal to 0. So how we write the domain here, you will say x, because we're talking about x values. You will say x is element of all real numbers. X is element of all real numbers, but x, it can't be your asymptote. What is the asymptote? 0. So in this type of question, always you will have it as 2 marks. Always you will have it as 2 marks. 1 mark to indicate that x is element of all real numbers, but x, it can be the asymptote. Then you have 2 marks there, always. And then now, when we're speaking about the range, we do the same thing. Range, we're talking about y values. Remember, on the y values, this graph is defined in all the y values. Y is element of all real numbers, but y, it can't be your asymptote. What is your asymptote? 1. And then even there you get 2 marks. So you see how we mark when we are asking you to determine the domain and to determine the asymptotes. So those questions in the exam, normally they carry 2 marks to determine the asymptote or to determine the range. And remember, the domain and the range. Domain, we're talking about x values. The range, we're talking about y values. And we check where the graph is defined, on the x values and the y values. So in this case, the asymptote, it means the graph is not defined there. And then the domain, the graph is not defined where x is equal to 0. The range, the graph is not defined where y is equal to 1. Where you have the asymptotes, the graph is not defined. Okay. Now, let's look at the second graph that we need to sketch. We apply the very same method. Remember now, in this case, this graph here, we have negative. And when we have negative, we agreed that it's supposed to look like that. The first thing that you need to do is to identify the asymptotes, to determine the x-intercept, and to sketch your graph. So now, looking into your asymptotes, always we saying x is equal to 0, 1 mark. Then now, how do we get the equation of y asymptote? Y is equal to -2. Another mark. Correct. Another mark. 2 simple marks that you can acquire there by just saying x is equal to 0 and y is equal to -2. That's how you identify your asymptotes. Then from there we can be able to calculate the x-intercept. So x-intercept, we know that your y is equal to 0. So we have 0 is equal to -2 over x minus 2. So this -2, we're going to transpose it. We're going to have +2. It's equal to -2 over x. So we can cross multiply or divide, multiply both sides by x. So 2x is going to be -2. Then we divide both sides by -2. 2 cancel 2. Then your x is going to be -1. Correct? So now, how are we going to sketch this type of a graph now? Remember, on this one, you're going to have 1 mark here, 1 mark here. Also, 2 marks there. Correct. So now, we agreed that for us to sketch this graph, the first thing that we do is to indicate your asymptote. X is equal to 0 and the other one was y is equal to -2. So those were our two asymptotes. Those were our two asymptotes. Then from there, we determine the x intercept where we have -1 there. Where we have -1. And then now it means our graph will come like this, pass by -1, and then also come this side. That's how we are going to sketch our graph of hyperbola. It must pass through -1. It must pass through -1. Give it a point there, -1 and 0. So you will have one marks there, 1 mark for 0 and 1 mark for shape. And then even here we speak about the domain. The domain where x is element of all real numbers, but x, it can be 0. The range y is element of all real numbers, but y, it can be -2. So that's where you get your marks. 2 marks here, 2 marks there. That's how you get the marks for the range and domain of this particular graphs. Okay? Now, we now have to determine the equation. We now have to determine the equation. Always, you must be prepared that in the exam they can ask you two different, this type of question in two different ways. The first one, they can sketch the graph for you and ask you to determine the equation, or they can give you the equation and say sketch the graph. So now, in this instance, we have to determine the equation of the graph in terms of y is equal to k over x plus p. I told you that these values here, they can change them. Don't get used to a and q. They can change them. They can play around those variables. So you must know that they mean the same thing. So in this case now, for us to determine the equation, the first thing that you need to identify there is the asymptote, which is going to represent the value of p. And then 1 point on the graph, that is going to help us to get the value of k. So now, in this case, we know that our p is equal to -3. So we're going to substitute it as k all over x minus 3. That's how we do it. And then now we have a point there as x and y. And we need to get the value of k. How are we going to get the value of k? We're going to substitute y, which is -5 all over 3. It's equal to k all over x minus 3. K all over x minus 3. So what will happen here? I will just take this -3 and transpose it. I will have -5 over 3 plus 3 is equal to k. Okay, sorry, where there is y we put, where there is x we put 3 all over 3. That's how we substitute. Remember, I'm substituting x and y. So our x is our x is 3, our y is -5 over 3. So that's how I substituted. Then the unknown is k. So we transposed this negative to the left-hand side and it became positive. So now you will just have to go to your calculator and say -5 over 3 plus 3. Then you will get 4 over 3. You will get 4 over 3 is equal to k over 3. So now, when you cross multiply, you're going to have k, 3k is equal to 12. Then we divide both sides by 3. Then therefore, k is going to be 4. Correct. So it means now we're going to substitute our k there. The equation is going to be what? Y is equal to 4 all over x minus 3. So that's how you're going to get the equation there. That's how you're going to get your equation there. So you see, it's as simple as ABC on how to determine the equation from the graph. Correct? So now, always, you're looking into your asymptote and 1 point on the graph. That is the end of the lesson. I hope you have enjoyed this lesson. We learn by repetition. Go and practice more the graph of parabola and hyperbola. Thank you.